Welcome to the Kubernetes Training. Here, a little introduction about me. I have 5+ years of engineering experience in DevOps domain and site reliability engineering. I have 2+ years of professional training experience where I have given various kinds of training to the students, freshers, as well as the working professionals, where I used to go through all the points, what Kubernetes is, how it works, how we can set up a Kubernetes cluster, and certain POCs and demo. And yeah, so I have, worked in the industry for quite large and for, I can say, very huge infrastructure where the cluster spans to 20 to 30 Kubernetes clusters. So I can give you more in-depth ideas about what are the Kubernetes processes, what are the issues we face, what are the troubleshootings we follow, all those things, and I'll give you the live demo for all of the Kubernetes features like how to create pods, how to deploy an application, how to use auto scaling in Kubernetes. So let's talk about the scope of the demo of this training session. So the demo will reside with many topics where it will be having basic idea of Kubernetes. So what is Kubernetes? So, we'll talk about Kubernetes and in-depth concepts of all of its components. Then we'll talk about the virtual machines, containers, and pods, how the evolutions happened, how applications was getting deployed earlier, and how it is getting deployed now, and how the container concept and the pod concept has revolutionized the microservice application deployment, as well as how what kind of cost optimization and security we got once the Kubernetes came into the picture. And we'll for a personal demo, or we can say for a personal setup, we use Minikube, which will be done in any Linux or Ubuntu system, as well as if you have a Microsoft system, then we'll do support on Microsoft. We'll do installation on Microsoft system as well. Then we'll talk about the most relevant features of Kubernetes, which is like deployments, replicas, and strategy of application deployments and horizontal pod autoscaling. So all these are the backbone of application deployment in Kubernetes. We'll talk more about what kind of deployments are there and how we can basically design our deployment steps so that it can it can be a good fit for our infra requirements and our applications requirements, because every microservice has different architecture, different design, different behaviors. So we will get to know about how applications will get deployed. In that we will cover like mostly very highly used code bases, which is like Java, then Node, and then Python. And we'll talk about the replicas, like what a replica is in Kubernetes and how it works and what's the impact of a replica in Kubernetes. Then we'll talk about the strategy, like what kind of strategy we should follow so that our application can be available all the time, 99.99% of the availability. And after that, we'll talk about auto scaling. So how auto scaling works in Kubernetes, what kind of behaviors are there in Kubernetes for auto scaling, how we can do the resource optimization, how we can configure auto scaling so that our application should not get crashed or should not go down. All those things will be covered. Then after that, we'll talk about the storage part, where we'll be talking about the Kubernetes volumes, how volumes are got created, how volumes got attached to the container, how it works, what kind of volumes are there, what kind of different architecture we follow for the different applications in Kubernetes volumes. Then the resources, basically like what kind of resources available for the storage of data in Kubernetes. Then we'll talk about the most important part, that is security. So security is basically like we can say how we will create secrets in Kubernetes. What secrets are there in Kubernetes? What secrets data stores? How they basically have the details about secrets, what kind of secrets are there, how we can encrypt or decrypt our data which are available in the Kubernetes secrets, and then we'll talk about the config maps. Config maps basically like to how will store our data in unencrypted format in Kubernetes. And then the environment variables. Environment variables will be simply as what are environment variables we define in our system for running an application, how we will do it in Kubernetes, how the data will get fetched from the environment variable in Kubernetes pods and then the containers. And after that, we'll talk about the connectivity. So in connectivity, we'll cover services, load balancers, and networking. In services, we'll cover about what kind of services are there in Kubernetes available and how we'll be able to create a service, how we'll be able to attach a service to a pod or a container, then how what kind of service is required for my application, what kind of service we can use in what scenarios. So we'll talk about basically like according to our application, according to our platform, according to our code base, which service type will be good for us. And then the load balancers. So load balancers are very critical part of the production grade application where we load balance our application's traffic through the network traffic. So in that case, we'll be discussing about what and all behaviors are involved in load balancers, how ingress works, how we can set up ingress controller in Kubernetes, and then how what kind of load balancers are available in Kubernetes. And then we'll talk about the cloud-based load balancer. Suppose if someone is going to deploy their application in AWS, how they will deploy using their load balancer like application load balancer and network load balancer and classic load balancer. The same way in Microsoft Azure, where how they can deploy it in gateway load balancer and network load balancer. Okay. And then again, we'll talk about the networking part of the Kubernetes. So how all these things works in the Kubernetes behind the scene. Okay. Now, suppose I have deployed an application and I have exposed it. Now it is available to the internet via any node port or any kind of load balancer. Now I want to know how behind the scene it works. Like when the traffic comes to our application, how it comes to the Kubernetes cluster and then to the pod, and then how it responds to that for that particular application. And then we'll talk about the networking architecture of Kubernetes. So it simply says that how the networking architecture works in Kubernetes and inter-pod communication, inter-service communication, and inter-component communication. Then the control plane to the nodes communication, how all these things works in Kubernetes, and then how the API call happens, how these API calls go to the internet and then take response from the internet and then do the changes to our. Then we'll talk about so how our course will be outlined. So our course are outlined in various topics. We can say it as a chapter. So each topic is a chapter here. We'll discuss about each of them in an elaborated way. We'll talk about each and every chapter uh, in very detail so that you can understand all the concepts, all the topics, and all the resources. As well as we'll talk about more of the how so each sector will have a practical. I can say the practical means there will be an assessment, there will be a quiz, so that you can get to know, you can understand what all are the major terminologies in each of the chapters. Okay. So the course will be outlined in the same way. It will be like the introduction to the Kubernetes, where we'll talk about what is Kubernetes, how it works, and what it changed when it come into the picture. So what was before Kubernetes and what is after Kubernetes. Okay. Then we'll talk about the architecture and the core concepts of the Kubernetes. So architecture and core concept will be involved basically like what architecture, how Kubernetes is designed, how their components are aligned to each other, and how they have been uh, set up to provide a highly available cluster, and then the application deployment feasibility and all those things. After that, we'll talk about in details of each of the components, each of the services and the behaviors and features of Kubernetes, which will be covered in the core concept of Kubernetes. Then we'll do the installation. I'll show you the installation in our system. Then you can do in your own personal system. There will be installing the Kubernetes, and then we'll be discussing also about if we need a high available cluster, how we can do that setup. Because in this demo we'll be setting up a mini cube cluster that will be a very little just for personal use cluster. Then we'll talk about highly available clusters also. Then we'll talk about medium grade clusters also. Then we'll talk about industry based best practices, what we follow while we do the installation. We'll talk about resource allocation. We'll talk about the cost forecasting, how we do cost forecasting, how whenever we used to go to we used to go to set up a Kubernetes cluster, what things we follow, what requirements we follow, what behaviors we follow, all those things, so that whenever if you have to set up a cluster, or whenever you got work a task where you have to set up a cluster, you will have all this data available, you will have all this knowledge available, and then you will be able to take best decision out of it, and you can benefit your organization as well as your skills growth also. And then we'll talk about the setup, and then working with the nodes, where we'll with the cluster setup, which uh, it will basically give you the idea about when we do the Kubernetes cluster setup, what things are there which we need to consider, what kind of different scenarios which we need to consider as per our requirements, and then the nodes, like how Kubernetes nodes works, how what kind of computes we can deploy, what and all things we can integrate with it. And we will talk about the different cloud providers. Like right now in market there are a lot of cloud providers, and people are mostly moving to the cloud service solution. So mostly you will get chance to set up your cluster in a cloud environment. So we'll talk about that also. Like if we set up a cluster in a AWS based infrastructure, how that is getting done, and how what and all other things which are involved while setting up Kubernetes cluster, which has to be taken care from the AWS side. What authentication mechanism, what backup and restore mechanism which we have to take care at AWS side, what networking mechanism we have to take care at AWS side. And then with the nodes, when we talk about the worker nodes, we what things we need to consider uh, from the AWS side. So I can say here that we need how we will be able to go into those EC2 instances if we are deploying our cluster in AWS. How we'll be able to uh, access those nodes, and then how we'll be able to see if our pods are running, if our containers are running properly, if the system is configured properly, what kind of AMIs we have to use, what kind of security group setup, what kind of load balancer setup, all those things we'll discuss in this one, in this chapter. Then after that, it comes to the actual load deployment to the Kubernetes. In the fifth chapter, we'll discuss about uh, how deployment works, and then the core concept of the pod, which like we can say the Kubernetes is relies on pods only. So the base of the Kubernetes is pods. So the same way base of the Docker is containers, the base of the Kubernetes is pods. So we'll talk more about pods. What is pod? How pod works? How pod deploy the containers? What behaviors of pods are different than the containers? And then what kind of deployments are there? What kind of auto scaling behaviors are there? All those things we'll discuss in this sixth chapter. And after that, we will discuss about networking part. In the sixth chapter, will be elaborately discuss about the networking part, where We'll have a network diagram also where we will show you how the traffic in and traffic out works in Kubernetes, and how basically the things uh, like if you have deployed a pod, how it will get access via internet. If you have deployed an Nginx server, how that Nginx server will be proxied to the internet, how the request will come to that Nginx server. All those things we'll discuss in this chapter, as well as we'll discuss about the internal networking of the Kubernetes. So internal networking of Kubernetes is very important to understand before understanding the external networking. So once you will be able to understand the internal networking, it will be very easy for you to design your networking architecture for your cluster, for your company's requirement, for your organization's requirement, and for your future growth. Okay, so like if I say for future growth, it's like you will get the idea about how basic networking of the system works. Because if you go to the container is also a encapsulated image of a instance or a machine or an operating system. Okay, so if you understand the concepts of the networking in a container, you will be able to understand the concepts of networking in your system, in your operating system, in how day-to-day networks work, how traffic comes and goes out of a system. After that, we'll talk about the monitoring and jobs in Kubernetes. So in the seventh chapter, we'll discuss about all, this topic. So about monitoring, if I say monitoring is also very important. If you have set up your production grade cluster, you have to monitor your cluster regularly so that any issue has happened, any problem is coming up, anything is not good about your cluster, is not healthy about your cluster, you can immediately get to, and then you can immediately resolve it. So monitoring and alerting is also a very important part of your engineering process. Okay, so in that engineering process, we mostly cover about how we can monitor a Kubernetes cluster, how the Kubernetes dashboards getting deployed, how we basically uh, what kind of alerts we can set up, what kind of checks in our applications we can implement, like the readiness and liveness probes and all those things. All these things we'll discuss in this chapter, and then we'll talk about Kubernetes jobs. So you have heard about you have already worked, you might have heard about cron job in Linux system. You might have used also cron job. So the same way, there is a job features available in Kubernetes also, where we can create a job that will run at a particular time, or it will run for a single time and it will do your part. After that, it will have no relevance. Okay, so all these things we'll discuss in this seventh chapter. And after that, we'll talk about Kubernetes cluster in multi-environment, and we'll talk about the dashboard in more detail in the eighth chapter. So Kubernetes in multi-environment, we'll discuss like how how you can set up Kubernetes cluster in the multiple based environment, in the multi-tenancy architecture, and in multiple multiple location, locality based resources, instances, and computes. Then we'll talk about storage of how storage works in Kubernetes in the ninth chapter, where we will talk about how you can create a volume, how data stored in Kubernetes, and then how you can uh, mount a volume to your application, how you can uh, provide resources to your particular application. All these things we'll discuss in this chapter. After that, coming to the troubleshooting part. In troubleshooting part, we'll talk about we'll majorly talk about how you can troubleshoot your cluster. So once you have set up, troubleshooting is more important than the other part. So troubleshooting, where here in that chapter, we'll we'll talk about troubleshooting in more detail with a live demo. Okay. Like we'll create a scenario where application will get crashed, where problems, pods will have issues, where services will not be accessible, and where volumes are storage is not getting attached or it is not able to store the data. All these things, all these scenarios will create and will do a live demo so that you can have clear understanding of how troubleshooting works in Kubernetes. What will be the single point of check if we are going to troubleshoot our cluster? For because there are certain predefined issues, we can say, which we get to know immediately after checking the logs or after checking the state of our pods. So all those things will create the scenario and we'll test. Then we'll talk about workloads and schedulings. So workloads and schedulings are basically like how what kind of workloads and we can forecast our application deployments. We can forecast our workloads. If we have given that much of resources to our cluster, how much application traffic and how much application load it can bear, all those things, and as well as how the scheduling works. Basically, like I have scheduled a job, I have scheduled an application so that it can run at a certain of time and for a certain period of time. Okay, so all these things will be discussed in 11th chapter. After that, we'll do practice test where we'll be having many scenarios and we will create scenarios. You will have assignments, you will have practice deployments, you'll have practice application setup, you'll have practice cluster setup. All those things we'll discuss here. And then we'll talk about more about the interview questions, how to crack the interview. So basically all this knowledge are mostly important for enhancing your skills. So after enhancing your skills, it is interview is the, we can say, is our actual examination. So I'll help you to prepare here for your actual examination, the interview process. So I'll tell you about what interview questions are asked. If you are a fresher, if you are an experienced guy, what kind of questions you will face in your interview, what things you need to consider, how to answer the Kubernetes questions, what practical knowledge you should gain, what kind of like in interview questions I will discuss about how to write the manifest file, how to, if you have got a chance in your interview to write a manifest file or to update a manifest file or to manipulate a manifest file. So we'll discuss about all this in very detail in this chapter, where we'll be covering all the details about your interview related to Kubernetes. Now let's talk about the little idea about Kubernetes. What is Kubernetes actually? So we have talked a lot about Kubernetes or Kubernetes. So now let's see what is Kubernetes. So before Kubernetes, there was Docker, and before Docker, there was virtual machines. Then before virtual machines, what was there? Then there was legacy systems. We can say the system, the servers which were running in company's data center, and we were going to deploy applications there using a hard drive or or a memory chip or a floppy card. After that, virtual machines came where virtualization happens. So, in the concept of virtual machines are the same operating system which runs on our system in our own system with a virtualization. So, what is virtualization? Virtualization is basically like it's a replica of your operating system with, we can say, images running in your system. Okay. In that case, there will be isolation. The virtual system will be isolated to your actual system. You can define resources for it, you can define CPU and memory for it, and then you can run your application in your virtual machines. And we can have more than one virtual machine in one system. After that, it came to the Docker container. So how Docker works? Docker works on the image base. So images are the stateless encapsulated manifest of our systems. We encapsulate our system files, our binary files, our operating system files in an image, and then we store it as an image. After that, we create container on top of it to make it stateful. Okay, so stateful means when a container comes into a process, it will boot all the files available in the image and as well as our application files. So the moment the boot up starts, it starts looking for the platform. Suppose if it's a Debian system, or it's a Linux, it's a Ubuntu system, or it's a Windows system. So it picks all the necessary process files and the system startup files, and then it boot up that particular image in the container, and then it start the container. So the container is started. We have defined certain applications in our container, where we'll be defining it in the entry point or CMD, or in entry point or CMD. So what happens is, like, whatever commands will pass to the container, it will run that. Okay. Now it's like it's more compact to the virtual machines. So yeah, so now we have containers, but how to manage these containers? How to manage these containers effectively, so that we can deploy our like 100 of the microservices with very compact storage solutions, as well as very easy to manage. For that, Kubernetes came into the picture. So Google designed Kubernetes and they make it open source. So what Kubernetes used to do, Kubernetes works on top of the containers. So on top of container, it creates a pod. So the container resides within the pod in Kubernetes. So here it's like it took the container as base, and it uses it uh, as a, you can say, base module for its pod, so that we can have, for an application, we can have all the dependencies deployed in a pod, where suppose if an application requires a sidecar application, if it requires a database, so both we can deploy within a pod. Okay, so that's that's what it's like, and it will be basically like the pod is more manageable than container. Why? Because we'll be able to allocate resources, we'll be able to attach volumes, uh, we'll be able to integrate environment variables in all those things in our pod. So basically, the basic idea of pod is to manage the containers more effectively. So that's where Kubernetes comes into the picture. Now, if you talk about the architecture of Kubernetes, Kubernetes is basically based on master and nodes architecture, where one will be master and another will be slave. We can say slaves are the nodes. Okay, so the master is basically like to manage all the resources available in our Kubernetes cluster. It manages networking, it manages storage, it manages application deployments, it manages API calls, and it manages the processes within the cluster. All these things are getting managed, and it is stores all the data, all cluster related data, data in master plane. Okay. Now comes to the two parts. So both of them have different components. So if we talk about the components of Kubernetes, so there comes control plane, is where all administration related resources run, and it manages the state of each and every process in Kubernetes. So what does it mean? It means that whatever is happening in Kubernetes, whatever is going out, coming in Kubernetes, will be managed and monitored by control plane. We can say the master plane. Okay, so control plane take cares of the scheduling, the deployments, and then the networking part, storage part, all those things, how it's happening, where it will be configured, who will be using it, or what will be done. All these things are being managed by control plane. Then the worker nodes. Worker nodes are basically the computes where our loads, we can say containers, pods, volumes, and other configurations will be running. And worker node will be a VM. It can be a VM, it can be a local machine, it can be a cloud instance. So the worker node will be basically like it can be a it can be a server which is running in the backend, and our applications will get deployed there on the worker nodes. So worker nodes will have storage also. Worker node will have volumes attached. Worker node will have high intensity RAM and CPU. Then we'll talk about the components of control plane. So component, the Kube API server. Kube API server is basically a API server. So let me tell you one fact that in Kubernetes, everything is a API. Everything is a API. It means that whatever service, whatever pod, whatever deployments, whatever config maps, or whatever routes you create, they all have a API behind the scene. So whatever internal communications happen between Kubernetes, they happen via API calls. So one service will call another API, another service will call their API, that service will call their API. So that is so that's why Kubernetes API server. API server manages all the API. API server checks for any request is coming, it converts it into API, it sends it to the particular requirement. Suppose if you have created a pod, it will send it to the first it will check the API and then it will send it to the scheduler. Scheduler will do the rest of the things. Okay. Now coming to the HCD. HCD is basically it's a old Linux term where Kubernetes is basically use it as a storage. So HCD is just storage of data for all of the Kubernetes related components as well as all the processes which are going in Kubernetes cluster. So HCD contains the records of each of our deployment pods, our volumes, our storage, our service, our process, our APIs. All these things are getting stored in HCD. Control plane uses that HCD for the state management. So suppose you may say that you have created a manifest file where whenever you run that manifest file, it deploys a pod. Okay, so that pod. Now, how Kubernetes will get to know that what last data applied to that pod, what configuration is running for that pod. So that all these things getting stored in etcd. So whenever now after some time you needed a change, you wanted to add an environment variable into that pod. So what will happen the moment you will add the environment variable and rerun it again, it will take the data from HCD for the last state and then it will apply that particular change in that available data and then it will store it again with the new data. So queue scheduler is basically it's the scheduler which used for scheduling all the processes, all the operations, and then the request, whatever request it is getting. Suppose got a request to create a deployment, then there will be a pod in that deployment. So to allocate that pod, the schedulers comes into the picture. It checks for all the resources, it checks for all the computes, and it checks for the worker nodes where the resource is available. Then it assigns that pod to that worker. And then comes to the controller manager. So controller manager task is to simply control all the operations from API server to the network operations. It will be controlled by Kubernetes Controller Manager. Now coming to the Cloud Controller Manager. Cloud Controller Manager comes into the picture when your Kubernetes cluster is getting deployed in a particular cloud. Suppose if I am going to deploy our cluster in AWS, which is like EKS managed, Elastic Kubernetes managed cluster. So in this case, there will be a cloud controller manager for AWS. So what cloud controller manager used to do? Cloud controller manager, it gives us a simple idea about, we can say, how the inter operations will happen between AWS and Kubernetes. So inter operations between AWS and Kubernetes, which means to say that if you have created a load balancer, how that will get integrated in AWS. If you have created a volume, how that will get attached to AWS system. So all these things, and again, there is a service in AWS which you want to integrate with your Kubernetes pods, with which you want your application to access. So how your application can access a file available in AWS S3. All these things are being controlled by Cloud Controller Manager, and we'll talk about all these integrations in throughout our training. We'll talk about how you can copy a file from your S3 to your application, or you can push data to S3 file from your Kubernetes application. Uh, so these cloud components, they are basically they are newly added features of Kubernetes, where when the managed Kubernetes services came from the different cloud providers. Okay, so basically, like for each of them, earlier it was the traditional way where we were deploying Kubernetes clusters in all of the cloud-based providers. But after cloud-based providers found new solutions where they can provide their managed services, we like the Kubernetes got integrations for them. So they have started providing all these components. Uh, they have started providing the cloud controller manager for that. Cloud controller manager also do the worker node controller. The worker node controller is basically, we can say that how the nodes will get deployed if a node got its resources full, or how auto scaling will work when like when the application got deployed on that particular node is consumed. It's consuming the resources, then how the auto scaling of the computes will work, how auto scaling of our resources will work. And again, the routes controller, it basically gives us the idea about how our routes from Kubernetes to the external traffic, and then from external traffic to the Kubernetes will work. And then the service controller, where like how our load balancers will communicate to our Kubernetes cluster, how it will take the request from our Kubernetes cluster to the external world, and then take the traffic from internet to our Kubernetes cluster. Then it comes to the nodes, worker nodes components. Worker nodes components is like the kubelet. So it is an agent that runs on each node in the cluster, and it makes sure that containers are running in the pods. So I told you, basically the base of Kubernetes is pod, but pods uses containers in itself. So the base concept of Kubernetes is also containers, but containers are not the directly integrated things of Kubernetes. So that's why there is kubelet. Kubelet is a component which always it's all the time it maintains that the Docker containers are running in our Kubernetes pods. For that, kubelet is coming to the picture, and it takes the pod specifications each time, and it checks for the specification and then the state, where in the pod state there will be status of the pod. In that status of the pod, the status of containers will be there. So from that status of containers is fetch the current data. What is the current data of that container? If that container is in waiting state, if that container is in running state, or if that container is in stop state. So it checks for that, and then if it is in stored state, or if it is in waiting state, it tries to make it up all the time. And then again, the next is the queue proxy. So queue proxy is a network proxy that runs on each node. Okay. So network proxy. What is network proxy? Again, I told you, if you have a little idea about Nginx proxy, how Nginx proxy works. Nginx proxy takes the data from your existing system and proxy it to the internet. And if any request is coming to that Nginx proxy, it proxy it to your system. So the same way Q proxy. Q proxy is also, I can say, it's the implementation of Kubernetes service concept, where if you like throughout our training, we got to know about what is Kubernetes service, how it works, what kind of services are there in Kubernetes. And then proxy maintains the network rules on the nodes. So whatever rules you have created in your service, if you have for a particular pod, if you have created a, suppose for a particular pod, if you have created a service where it will be exposing only port 80 or 8080, so that rules will be managed by proxy. All those rules will be provided to that particular node where the pod is running, so that whenever a request is coming or it is going out, those rules will be applied. So if a request is coming, it should come to 8080, otherwise it will refuse the request. It will say that the service is not available. And then the third component is container runtime. The container runtime is the software that is responsible for running containers. Okay. Again, I told you the kubelet, which ensures that the container is running in pod. Okay. Now the container runtime. Container runtime is a software that makes containers running all the time. Okay. So it makes the container running. Whenever you created a pod, a container will spin up, and then container runtime will make that container running. So it will create the configurations of containers behind, like what image is there, what commands are there in the containers, all those things it will be managed by container runtime. About the deployment via CI/CD. So now we have set up our cluster. We know how to deploy applications. But again, it came is there like if you are working in an organization, and if you are doing frequent changes in your code, and if you want it to be deployed automatically, right? So in that case, there will be that Kubernetes deployment via CI/CD. So we talk about end-to-end GitOps, where it's like for any organization to, automatically integrate their applications, integrate new features, integrate new fixes to their applications. Uh, we need to follow the CI/CD process, which is like continuous integration and continuous deployment. So in this slide, we'll discuss about how we can implement CI/CD in Kubernetes. So Kubernetes applications are basically they are managed by manifests behind the scenes, and we can use that manifest also to deploy our applications, as well as we can use the Kubernetes uh, CLI, which is kubectl. Using kubectl command also we can directly run to edit the image, and then our applications will get updated. So when we talk about a CI/CD for a Kubernetes-based application, which is like mostly a microservice, we say that our CI/CD part, our CI/CD automation should be designed in the same way, where the pipeline should include the multiple stages. So in that multiple stages, there will be build part, where we do the basic building of our codes, and then we build the Docker image out of it. Then we do unit testing code base our new based application, so we can so that we will be able to understand that what and all features are new fixes we have introduced, they are working fine, and then we deploy our application. So in the deployment part, basically how it should be getting updated directly to our Kubernetes cluster. So here we have multiple enterprise and as well as open source based source code management, as well as CI/CD tools. All where I can say for the open source there will be Jenkins, GitHub, and GitLab. As and at some extent, Bitbucket also provides open source, and then the Circle CI is there. So we can use any of this CI/CD tool, and we can set up our pipeline in that. We can set up our build jobs. We can set up our test jobs. We can set up our analysis job, where we'll do code analysis, and then we can set up our deployment job. So in the deployment jobs, we can have different kind of Kubernetes deployment processes, where you can use YAML manifest, Helm package manager, and then kubectl CLI. In YAML manifest, what happens is like Kubernetes is managed by the configuration. So that configuration is behind the scene get converted into JSON, but it supports YAML also out of the box. So in the YAML configuration, we basically provide a YAML file. That YAML file will contain all the details about our application. Okay. If we are deploying a pod, there will be a specification of pod, what and all environment variables, what and all volumes storage, what and all secrets we have to set up, how many replicas of pods will be running, and as well as how many what and all volumes are integrated to our pods. All these things will be configured. After that, the Helm package manager. Helm is a new way to deploy our application. So suppose our application is having multiple dependencies. It simply says that whenever I deploy my application, there is another dependency that should also get deployed. There is a database that should also get deployed. So there comes help into the picture. With the help of help, we can integrate all of these components of a application and we deploy in one shot. So that is the Helm package manager. And then the kubectl CLI. Kubectl CLI is basically like the CLI of Kubernetes, where we run the kubectl command, Kubernetes CLI commands, and we update. So in this training, we'll talk about add-on topics where it will be like how the CRDs work in Kubernetes. CRDs are mostly custom resource definitions, where we create our own Kubernetes APIs and our own Kubernetes-based resources. Then we'll talk about Kubernetes best practices, what things we need to follow to deploy our clusters in a best suited way. And then we'll talk about the resource manifests. Resource manifests are like how we can write our YAML files, how we can write in the JSON file, how we can read those YAML files, what indentations we have to follow, what are the best practices to write the manifest files. Then we'll have projects also. We'll be deploying an microservice based application in Kubernetes with a database configuration and all the other features like Kubernetes secret, config map, volumes. Then we'll deploy Nginx web server and we'll showcase how a web server works in Kubernetes using Nginx. Then we'll deploy application behind that web server and we'll check how the proxy is happening. And then we'll deploy a multi-container based application where a pod will have multiple containers and how it is running. Well, it will have a sidecar container, it will have an actual container, it will have other features of multi-container. We'll have lab setup requirements. We need a personal system, and then in the systems requirement, it can be Linux system, Windows system, or Mac system. Then for setting up any Kubernetes cluster, even Minikube also, we require minimum of 2 core of CPU and 4 GB of memory, and then at least 100 GB of memory should be available for deploying different applications. So we'll talk about mock interview questions that I already discussed. And then the Kubernetes supports multiple certifications, which are like Certified Kubernetes Administrator and Certified Kubernetes Developer. So we'll talk about these also, how you can go for CKA and CKD, all those things, what are the exams related questions, how the things are covered, and how what topics have what weightages, and all those things we'll talk about in that slide. And then after the course completion, you will get a course completion certificate which you can showcase as a skill for yourself. That's all.